Hello everyone, this is Aarohi and welcome to my channel. So guys, in this video I'll show you how to develop your own mobile application, object detection mobile application using YOLOv5. So the topics which we are going to cover in our today's class are first we train our YOLOv5 model. After that we will convert that YOLOv5 model into a TensorFlow model. And once we have that TensorFlow model, then we will convert that TensorFlow model into a TFLite model, and this TFLite model we will use in our mobile application, Android application, to make it as a object detection app, right? So let's begin. So first let's discuss about the dataset. So the dataset which I'm using for today's classes, that dataset have 12 classes, and some of the classes are apple, banana, cucumber, eggplant, KitKat, Maggie, mushroom, orange. These are few classes of that dataset. Let me show you that dataset first. So this is the dataset here. So guys, what I have done is I've created one separate folder. Just create one folder. Under that folder you will place all your code which is related to our today's class. Okay, so I have created this folder, YOLOv5 PyTorch to TFLite Android app. Under that I have one folder with the name of dataset. This dataset folder, when you'll open it, you'll get two folders, train and val. Train is used to train a model, and on val folder we will do the testing. Okay, so when you'll open this train folder, you'll see two folders again. One is images and the other one is labels. If you'll open this images folder, you will see the images. All the images are here. Okay, and when you will open the labels folder, you will get the labels corresponding to each image which we have in our images folder, right? So this is the annotation file. Basically, if you'll see, these are the annotation file. I have opened the first text file and you will see like this. This is the class name and these are the bounding box coordinates of it. Okay, and guys, if you don't have a dataset and if you want to prepare your dataset in the format which YOLOv5 accepts, then you can use label image tool. You can simply install this tool by writing pip install label emg and you can start annotating your dataset and you'll get your own dataset. Okay, and you have to paste it like this. Under train, these two folder, images will have all the images, labels will have all the text file annotation files. Okay, in the same way, if we'll open this valid folder, again images and labels have all the labels, and under images we have the images on which we want to perform the testing. So this is my dataset on which I'm working. Okay, now you know about the dataset. Now let's see our code, how to work on it. Okay, so for that, this is a Jupyter notebook I'm using. I'll share the link in my description section. You can take this code from there. Okay, so I'm starting with importing the torch. So why I'm importing torch? Because YOLOv5 runs on PyTorch, so you need to install this PyTorch. So the PyTorch version which I'm using is, you can see over here, I'm using 1.8.1 PyTorch, okay, with CUDA 11.1. so I'm using GPU RTX 3090. so with my GPU, this is the compatible version. In the same way, if you're working on CPU, then install the PyTorch version which works with CPU. And in the same way, if you're using different CUDA versions or whatever your PC resources are, according to that, choose the PyTorch version. Okay, so once you install the PyTorch version, you need to clone this GitHub repo. This is the YOLOv5 GitHub repo from Ultralytics. We are installing this. Okay, once you have this, clone this GitHub repo, you will see one folder like this. See, YOLOv5 folder again. Okay, so dataset folder, the another folder is YOLOv5 folder, and under YOLOv5 folder you will see these files and folders. Okay, now the next step is, once you enter into that cloned GitHub repo, the YOLOv5 folder, you need to install the requirements.txt file. This file is already present in that folder. You can see here. Okay, here. Okay, so you need to install it, and after that once you install the requirement, I'm importing all the required modules, and this is the command for training our algorithm. Okay, so what we are doing is python train.py. okay, and then image size, you can change the image size over here as per your dataset, right? And the batches, so guys, you can change the batch size. Sometime you face memory issue, then you can change the batch size as per that. Number of epochs you can define as per your need. And then we have this dataset.yaml file. This file you have to create. Okay, so how to create this file? Just go there. So let me open this dataset.yml file for you. So this is my file, train. And well, over here you have to define the images which are present in train folder, right? Which path you have to give here? The images of the train folder, and in this val you have to give the path till the images of val folder, and number of classes of your dataset. So in my case I have 12 classes, and then you have to define the name of these classes, and this should be a dataset.yaml file. Okay, so this is the file. So that file we are giving over here. And then this weights, you have to download these weights from internet. You can get this weight from this repo only. From here only you can get this weight file. Okay, so now my algorithm is getting trained, and you can see after 50 epochs, let me scroll down directly. After 50 epochs, you will have runs folder under your YOLOv5 folder. Under that you will have train folder and then exp folder. There you will get the saved weights. Now let's open it and see. So this is the run folder. Open it, train folder, and then we have exp folder. Okay, so this, so my latest code is in this folder, so I'm opening this. Under this you can see you have one weights folder. When you will open this weight folder, you will get two weight files, last.pt and best.pt. This pt simply means PyTorch model. Okay, so and over here you can see the different other things like the related confusion matrix and you know, the other results. Everything will get stored over here. All right, and let me show you the kind of results we are getting. So this is the one of the some of the images from the val folder you can see over here, right? So our algorithm is detecting. Now if you want to perform the testing of this YOLOv5 model, how we perform that testing? For testing we use this detect.py file. Okay, and we want to use which weights now? The weights on which the weights created just right now after performing the training, we get one weight file, right? So now we want to use those weights files. So it is in run train exp2. Under that we have weights file, and I'm using best.pt from there. Remember this from here, right? Run train exp5 weights and then best.pt weights. Okay, and confidence score you can change it over here, and then you have to give the path of the images where you want to perform the testing. So I want to perform the testing on the test images folder which is present in exp2 folder. Okay, so now let me open this folder and show you. exp2, right? Run train exp2 test images. On these images I want to perform the testing. Okay, so we are performing the testing. After performing the testing, results got stored in this folder, runs under run detect folder and exp8 folder. Now let's open that. Runs, detects, exp8, and let me show you the results. Okay, just give me a second. See, so these are the few results from our algorithm. This is how our algorithm is performing testing, right? So now our algorithm is ready. YOLOv5 algorithm is ready, and we have trained our model, and we have used the test command also to check if that model is working correctly or not. Now the next step is to convert that .pt model, the PyTorch model, into a TensorFlow model. TensorFlow model means .pb model. Okay, so .pb simply means it is a when we say this .pb model, so .pb basically stands for protobuf, and in TensorFlow this protobuf file contains the graph definition as well as the weight of the model. So what our task is to convert the .pt model into a .pb model, and this .pb model simply stores the graph definition and weights of the TensorFlow model. Okay, so now let's do that. So for that you have to execute this command, python export.py. This export.py file is already present in your YOLOv5 folder, this. So we are using this file. Okay, now using this file, what we want to do is, we want to, what weight we want to convert? The weights, this best.pt weights, which is present in exp2 folder. And if you want to convert it into a TFLite, then you have to mention like this, include TFLite and then the image size. Just execute this command. Once you execute this command, you will get a TFLite weight, and it is stored in over here. You can see YOLOv5 runs train exp2 weights. Under this weights folder you will get a TFLite weight. Let me show you. YOLOv5 runs train exp2 weights, and now you can see we have this TFLite's weight over here. Okay, and now we have the TFLite model now. Okay, sorry guys, before that I have to show you this thing. Just give me a second, let me show you. So what we are doing is, we are converting it into a TFLite, and here you can see the TFLite weights. It's saved over here. Okay, and this folder will get created itself, and under this you will see this pb also. Okay, so what I have told you just now, that first we will convert the .pb, right? We will convert our YOLOv5 weight into a TensorFlow weights. So by executing that command, it will execute this step by default. Okay, you will get this .pb file, and from .pb file it will give you this .tflite weights also, right? By just one command, by running this one command, you will get the .pb file also, and after, from that pb file, from the TensorFlow model, you will get the TFLite weights also. So now we have a TFLite with us. Okay, now let's test our this TFLite weights. Okay, so for that, again what we are using is, we are using the detect.py file, which is present in our YOLOv5 folder, detect.py. okay, we are using this file, and what weights we are using this time? We are using the TFLite weights. Okay, and again, on which folder you want to perform the testing? The folder which is present over here. So this is the same folder we have performed the testing on the images which are present in test images folder when we test our YOLOv5 model. See, we are performing the test on that only, and with TFLite model also we are performing the test on that only, and the results will get stored in exp9. When you execute this command, you will get another folder with the name of exp9 under this detect folder, and there you will get the results. Let's see this exp9 folder now. Runs detect exp9, and you can see our results of TFLite model. Now our TFLite model is also working fine. Okay, so our model is ready. Now the next step is to use this model into a mobile application to make it a object detection mobile app. Okay, so for that you need a Android Studio. So guys, you can download and install Android Studio, and once you install the Android Studio, then okay, let me show you one more thing. After that you will have one folder, this Android folder. Okay, I'll give you this Android folder. You have to place this Android folder in your YOLOv5 folder. Okay, the GitHub repo which we have cloned and we are working on it. Under that folder, inside that YOLOv5 only, just copy it from here and place it under your YOLOv5. Okay, we will have this Android folder is containing a code of a mobile application. So again, I have given the link in my description section. So from that GitHub repo, you can take this Android folder. Okay, so now what you need to do in this Android folder, open this Android folder. Under that you have app, open that, and then open this source. Under source, click on this main, and under main go to this assets folder first. Okay, when you will open this assets folder, here you have to place your TFLite weights, right? The TFLite weight which we have created, you have to place that TFLite weight over here. And one more thing you need to do, this custom classes. Okay, so let me open this custom classes text file. This is a text file, and here you have to write down the name of your custom classes which you have in your dataset, and one class in one line. Okay, so these are the two things you need to do at this part. Under assets, your weight file, the TFLite weight file, and the custom classes. This file will have all your custom classes. This is the first change you need to do. After that, go to this mains folder again and go under this Java, org, TensorFlow, Lite, examples, detection. You have to come here and you have to open this detector activity.java file. Okay, when you will open this detector activity.java file, here you have to make a few changes. Okay, so those changes are, give me a second please. Just Control F and find this label file name. Okay, so just a second. Alright, let's go back and see if I'm working on a correct. Okay, just go in this TFLite. Okay guys, you have to go under detection, you have to go in this TFLite. Okay, over here you will get detector factory.java. So this is the file, open this file. Okay, over here, see, first of all what you need to do, you can see here, you have to define the path of the custom classes.txt. remember, so this is the file which we have created, which have the list of all the classes which are present in your dataset, right? And it is in assets folder. Just write the name of that file in which you have defined your custom classes. Okay, over here also, here and here, and just give the path of your TFLite model over here. That's it guys, these are the few changes which you need to do. Once you do these changes, after that your Android application, object detection Android application will work. Right now let me show you how to test your Android application, and for that you need an Android Studio. I have told you already that you need to install the Android Studio. Once you install the Android Studio, right, so this kind of screen you will get, and after that, see over here, I have configured my device over here in the same way you have to. So this is the device which I'm using, right? So you have to connect your device over here, right? So my device is this, and after that you need to build the app and then you have to run the app, right? So over here, from here, process, my app is already running, so I'm not terminating the process, right? Otherwise, if your app is not running, you need to click the button over here, which is over here, and your app will run, and you can see that application on your mobile application. Now let me show you So guys, you can see here, this is my Android application and it is detecting a KitKat. KitKat is one of the class which we are detecting using this object detector. So in the same way, you can use other classes, and this is how this object detection app work, right? So I have given the link in my GitHub description section, the GitHub link, right? So you can get the Android folder from there and you can train your own model, and then you have to do just few changes in that Android folder which I've shown you, and you will be having your own object detection mobile application. Thank you for watching.